This is review number 1 for Unit 4. Good luck on your geometry test. So question number 1 says in order to enlarge a figure, so that makes it bigger, a scale factor means what you multiply by, it has to be more than 1. 1 is basically 100%, so if you want to enlarge it, it has to be more than 1. In order to reduce, which is to make figure smaller, this scale factor must be less. Like 0.5 would be half, or 50%. So it has to be less than 1. And in order to create a congruent, that means exactly the same size and shape, the scale factor must be exactly 1. Or 100%, and that'll keep it the same size and the same shape. Question number 2 says triangles can be proven to be similar. Similar is not the same as congruent by using the following properties. You can either use angle-angle, so that's when you have two angles of one triangle that match two angles of another triangle. You can have side, 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 where all the sides are maybe twice as big or 3 times bigger. They have the same ratio. Or you could do side, angle, side similarity. That is not to be confused with the 5 types of congruent postulates. This question says if A, B, and CD are parallel. That's actually really important. That means that this side is parallel to this side. When that happens, we get several angles that are equal. So the first angles I notice are C and B because those are alternate interior. You also have vertical, which gives us AA. And if you follow the Z, we can also get angle D is equal to angle A. So at least by AA, we know the triangles are similar. With that information, they want us to solve to find the value of X. So all I have to do is set up proportions using the sides. So the 6 in the little triangle corresponds to the X in the other triangle. The same way that the 7, notice it's between the 2 red marks, corresponds to the 9. So you just set up 7 over 9. To solve, you just cross multiply. And sometimes answers are fractions. In this case, they will be. So our answer is 54 over 7. The next part of the question says, what property shows that they are similar? And I already answered that. That was angle-angle similarity. And here it says solve for X. So the final answer is 54 over 7. Question number 4 asks us to plot the triangle T at those coordinates R and I, which I already plotted. Part A says dilate triangle TRI. That means make it bigger or smaller by a scale factor of 2. So basically all I'm going to do is double each of the coordinates for each one, and then it'll be twice as big. They then asked us to plot it, and then they want to know if they are similar or congruent. So I plotted the coordinates of T double prime at -2, -2, and again all I did, because it said a scale factor of 2, was multiply the original coordinates by 2. And what that did was that made a triangle's lengths, the sides, are all twice as long. So if you notice the triangle T prime, R prime, I prime is labeled at the top. Part B said, are they similar or congruent? And I made a note that they were definitely just similar. And that's because they're not the same size. And that's because we dilated them. This question asks us to find the area of the shaded region. So the first thing we need to do is we need to find the area of the big shape and then subtract the area of the small. In this case, the big shape is a triangle. So remember, that's base times height divided by 2. And the area of the small shape, which is the inside, is just a rectangle, and that's base times height. So I'm going to find the area of each one. The base of the big triangle is 8 and the height is 6. So this would be 8 times 6 divided by 2, which is a total of 24. The inside area is just 2 times 4, which is 8. So the area of the shaded portion would be 24 take away 8, which is 16. Question 6 asks us to find the area of the shaded region. So again, we need the area of the big piece, which happens to be a rectangle. So that would be base times height. And then the area of the small, the inside is just a triangle, so that's base times height divided by 2. So the area of the bigger piece is 9 times 4, which is 36. The area of the inside, that's this part right here, is 6 times 2, and don't forget to divide by 2, and that's 12 divided by 2 is 6, so the final answer is just 30. Question number 7 says we're given this diagram. They want to know which theorem or postulate can be used to prove that triangle ACE, that's this big one, is similar to the little one BCD. And hopefully you can see that they look pretty similar. In fact, I'm going to separate them because I know I need it for the second part to solve for x. So if I take the big triangle, this whole side is 8, and that's because I added 2 and 6. The other side would be 7 plus x, because you have to add to get that. We don't know the bottom, and on the little triangle, this is a 6 and this is a 7. So before we try and solve for x, which this asks, they want to know why they are similar. That's what that symbol means. And the first thing I notice on the diagram are these arrows right here. And arrows mean that the lines are parallel, and that gives us some angles that are equal, because those would be corresponding. This is the big one, and that corresponds to this one. On the other side, you have also 2 more corresponding. So I know these triangles are similar by AA. In fact, you could use the top angles because they overlap up here. That's the same as this one, and you really have AAA. But remember, we only need 2 angles. So in order to do this, I'm just going to set up a proportion. The side 8 in the big triangle corresponds to the 6 in the other triangle, the same way that 7 plus x corresponds to the 7. Now I'm just going to cross multiply and solve. So when I cross multiplied, I got this work right here. Don't forget to distribute the 6. So when I subtracted and solved, I got 14 over 6, which is the same if you reduce it to 7/3, which is the same as 2.3 repeating. Question number 8 says Jason wants to determine the height of the Great Wall of China. He knows he can use similar triangles. Jason is 6 feet tall and his shadow is 10 feet on the ground. So I'm going to draw a little picture of that. So first of all, I'm going to have the Great Wall here, and I know it has a shadow, and that's going to be the same as Jason and his shadow right there. So Jason is 6 feet and his shadow is 10. You can make this longer if you want. So obviously the shadow on the wall should be longer there. And then we're going to put the information they gave us about the Great Wall. So it says at the location where Jason is, the shadow of the Great Wall is 27 feet. So this must be 27. What we're looking for is how tall is the Great Wall at that point. So since I really have 2 similar triangles, and the main reason is, first of all, the sun is coming down and giving us this angle that's the same in both, and there's a 90-degree angle, we can say by angle they're similar. We just have to set up proportions. So x goes to 6 the same way that 27 goes to 10, and you just cross multiply to solve. So when I cross multiplied, my final answer is 16.2 feet. That's how tall the wall would be at that point. Question number 9 says here's a set of different triangles, and they want to know if any of them are similar. And if you notice, on all of them, all the sides are marked for us. So we want to know if any of them by side similarity are similar. So what I have to do is compare the sides. And I always compare the big side of one to the big side of another. And I check the ratio and compare that with the small to the small side and the medium to the medium. Notice in the first triangle, the largest side is 18. And in the second triangle, the largest side is 12. So I'm just going to compare, and you could use a calculator, 18 to 12. That's the big and the big. The smallest of this one is a 12 on that side, and the smallest of this one is an 8. So that means I have to compare 12 to 8. And then the last ones I have to compare are 15 to 10. And what I'm going to do is change each of them to a decimal and see if they're the same ratio. When I compare and get all the different ratios, I get 1.5 for each of them, and that would mean that the bigger triangle is 1.5 times bigger than this one. And since all the ratios are 1.5, I know the first two are similar. Now I just need to compare one of them to the bottom. If the first two are similar, then if this top one is similar to the bottom, then all three will be. So I'm just going to compare again the big side to the big side and set up all the different ratios. So when I do that again, I compare the big side of the large one, which is 18, to the biggest one on this triangle, which is 6, and when you reduce that, you get 3. I then did the smallest, which was 12, compared to 4. 12 over 4 is also 3. And the medium, 15 to 5, is 3, and that means they're also similar. So the answer to this question is yes, they all are similar to each other. And they're all similar because you can compare their ratios. If this triangle is exactly the same shape but a different size than this one, and it's the same as this one, they're all similar to each other. So actually I can change the similarity statement like this, and I could say that they are all similar. So in the end, I can say that all of these triangles, and be careful that you go in the right order because you want the right angles to correspond, that all of these are similar to each other. And the last comment I'll make about part B, it says not all of these are similar, and I disagree with that. I will double check one more time, but I believe all of them are similar to each other. If one of them wasn't, then I would just show the ratios were not the same. But since these are all 3 to 3 to 3, and the ones above it are 1.5, 1.5, 1.5, then all three are similar to each other. And the last thing you'll notice is if I compare these two, right here, notice that the largest side here is a 6 and the largest is a 12. That's twice as big. The smallest is a 4. The smallest is an 8. That's twice as big. And 5 to 10 is twice as big. So all of these are definitely similar. So the bottom part B, was a mistake.